I first met Celus around 1.5 years ago at a university event. We invested last year, and now they've really scaled their team, have implemented a very strong culture, and now are ready to put their vision into reality. Joris, tell us more about your solution and how you can help to transform PCB designs.
Yeah, thank you. Thank you, Caro. Thank you very much for the introduction. I'm very happy to be here and introduce Celus to you and your audience. Let me share my screen and let's get right into it. All right, I hope you can see my screen.
Yes, works perfectly.
Very good. I guess most of us have heard the sentence that software eats the world. And I mean, it's true because in the past decades, software solves and solved many of our challenges we have been facing, we are facing. But software has a huge bottleneck, and that is that it simply does not run on toast. It runs on complex electronics. And as you can imagine, designing these electronics is also not a piece of cake. So if we look at the, let's say, average design process, it takes an engineering team about 6 personal weeks to get the project done and ready for manufacturing. With Celus, we bring it down to one single day. How do we do it? Well, we have seen that we can take concepts from software engineering and bring them to electronics engineering. As you can imagine, if you think about a software code file, you can take snippets out of it and place them and reuse them in a new project. And the same thing applies to electronics. You can take one entire electronics project, cut it into sub-circuits, store it in your library, and reuse it. But here comes the kicker. You cannot simply cut and paste these sub-circuits. You also need to understand how these sub-circuits are supposed to be used, how they work together with other sub-circuits. And for that, we have an artificial intelligence which understands it and enables us to choose those sub-circuits which are right for your project. And this basically looks then like this. We take a functional approach in designing electronics. I guess a device which most of you have touched today might be a coffee machine. How would you functionally describe that? Well, in a flowchart, you could describe, I press a button. This would then turn grinders, which will grind the coffee. The water is heated up and pushed through the grinded coffee to produce your hot beverage. This can be described in a flowchart. And what you get out of it is the electronics you need. And the best part about it is that we speak electronics. So the output can be used by all your engineers and enhanced because we will export the file into the format of your CAD tool. This, of course, also counts for the import of your sub-circuits into our library. So what does it mean for you? Of course, faster time to market. You will always beat your competitors. You have more time to generate value for your product. The time you've gained, you can spend on sub-circuits, which will increase the value of your product, where you can place new innovations and use other sub-circuits which will just complement your project. And I cannot press this fact enough. We enable smart reuse of previously qualified sub-circuits. It's not easy to just taking sub-circuits and placing them in the project and hoping that it works. It just does not work like that. So even if your colleague sits next to you, he might be able to tell you how that sub-circuit is supposed to work. And if you're lucky, you understand it and you use it correctly. That gets even harder once you are working on a different site, or currently as you're working remotely. So being able to use these sub-circuits in a smart way enables you to engineer electronics and make it a piece of cake. And also very important, the knowledge about your company IP is preserved. Because in the current state, all the knowledge of how these sub-circuits are supposed to be used stays in the head of your engineer. And once he leaves the company, either for retirement or he's switching the company, that knowledge will go with him. And with our tool, it will stay within your sphere of control. We've come a long way in the past 2 years since we were founded, and you can see here what kind of improvements we've achieved in the last couple of years. And this is only possible with this excellent and dedicated team which we have in the background. And we are happy to push basically the vision of electronics engineering in a simple way and make it available basically for all the engineers out there. So after this event, and if you think about all the pitches you've seen today, I hope you will remember at least the next 4 things which I will mention to you. So the key takeaways for you are: the electronics development process requires change. And this change will be at least as disruptive as the developments in the software world in the past decades. And Celus drives this change. And if you look at your products in your portfolio that require a plug or a battery, you should probably talk to us. Thank you very much. I'm very much looking forward now to the Q&A, and thank you.
Thank you so much, Joris. We already have one question for you. What is the minimum qualification to work with your engineering automation?
The minimum qualification in the sense of how much knowledge I need to in order to use the tool?
Yeah, so I guess if you have to have an engineering background, or what do you need to use the tool?
I mean, it depends on the complexity of your product. I mean, I'm not an engineer, but I can use this product. If I understand what kind of function I want on my board, I'm ready to go. That is the minimum requirement. Of course, we will export a board, and if you want to use it like it is, you can. But there are also things you need to be aware of. Let's say, for example, temperature on the board, and you need to understand how that works and how you should do some placements or maybe change some routings. Therefore, we export our result into the CAD tool of the customer, so he can make the last tweaks which are important to him and which make it, let's say, who can finish it in the correct way. But for the first prototypes, it is totally enough to have just understanding of what the function is supposed to be.
Thank you very much. One other question goes into the direction of complexity. You've already shown how the solution developed over the last 2 years, but what's the maximum complexity you can cover?
We can cover, well, high frequencies. For example, we can make sure that our system understands if high frequencies are in place. So we'll prepare a dedicated layer for that. We have proven in previous projects to generate projects up to, let's say, 10, 12 layers. We have not tested it with more in customer projects. It is theoretically possible to go to 255 layers, but we haven't tested that yet.
Very impressive. I'm looking forward to see how that works out. Maybe we'll wait like 1 more minute for maybe if there's another question. Otherwise, we would wrap it up. Hey, thanks. That's it, Joris. Thank you so much for your presentation. I think it covered it very well. Do reach out to him if, as he said, you have any product that is powered by battery, by a plug. Talk to them and use their solution for your future development. Joris, thank you so much.
Thank you very much.